everybody. Thank you so much for joining us. We have two incredible presenters with us today. We are really excited to get started. But as we settle in, I am going to direct you to the bottom of your Zoom window. If you navigate to the bottom of your Zoom window, you'll see what looks like a chat bubble. Go ahead and click that chat bubble, and that's going to open the webinar chat. That is going to be where we are taking questions today. So make sure if you have any questions, comments, suggestions, ideas, drop it in there. We are going to be watching that for the duration of the webinar, so that'll be the place to do it. And to practice this new skill, go ahead and navigate to that Zoom window and let me know. I did this on Tuesday, so if you recognize this question, it is perennial, evergreen, if you will. I want to know how many inches of snow you got over the weekend and how cold it is where you are. I think I'm stealing Noose's thunder here a little bit, but it's a low 40s right now here in Oregon, so not bad really. And no snow. So that is why Noose is over there making ice, or sorry, making snow. Cheryl shares that they got 8 inches and it's 9 degrees. Holy cannoli. Um, I ask you to drop things into the group chat for two reasons. One, because as you can hear, I am responding to people's questions, comments, etc. We love to not look like we're talking to ourselves. So please, when you share your question, comment, etc., in that chat, just make sure that little blue button there is set to everyone. That makes sure that everyone can see your question, comment, chat, whatever it is, and I don't sound like I'm just talking into the wind. Also, it helps us build community. Probably other educators are wondering the same thing, so we're kind of making it okay to have those questions and to wonder things. Okay, so I want to read some more chats here. So let's see. Sally shares that they got 10 inches of snow and it's 10 degrees. A very nice symmetrical number there. Chris says that there is no snow, but between 1 and 1.345 inches of snice, which is snow ice. Julia says that there are 8 inches where they are and currently 13 degrees. Central Pennsylvania got 10 inches and it's warmer at a whopping 18 degrees Fahrenheit. 18 inches, 11 degrees for Annette, 12 inches, 11 degrees for Anne. Nadine shares 20 degrees, so warm compared to everyone else here. And just a dusting of snow in Iowa. Let's see, Houston, Texas area, no snow, just a little ice, but they still got a snow day, so that is awesome to hear, Michael. Let's see, 70 degrees for Michael. Wow, 62 degrees in Subnet. Out of school week, good for you, Chris. More snow to come this weekend in Columbia, 11.5 inches, and they are a high school science special educator. Very nice. Thank you for joining us, Emily. Um, Did we really get 6 inches in Beaverton News? Oh, I see. 6 inches in the cylinder.
See, 6 inches of snow in Beaverton, Oregon, right there.
Right there.
It's like
The evidence
48
is
degrees
clear.
outside, but so there we go. All set.
All
All
right.
right.
Well, while I have you all here today, I would love to encourage you to go ahead, get settled in. As I said, leave me your questions, comments, chats in that chat box there. We are gonna have an eye on it. Could we go to the housekeeping items news?
Oh, I'm sorry. I'm
No, no
asleep. I'm
worries.
asleep. There we go.
Hey, you know what? It is a Thursday for all of us. So, as always, my friends, you are going to get a recording of today's webinar. It will be live on our website and on our YouTube channel. It usually takes us about 3 to 5 business days to get that edited and uploaded, but as soon as it's ready, it will be in both of those places. You are also going to get an email with a link to today's recording, so keep an eye on your inbox. Again, it just takes about 3 to 5 business days to get that edited. In the email that I'm going to send you here in about a week, you're not only going to get that recording, you're also going to get a resources folder, the link to which will be in that email as well as in the chat as soon as I'm done talking. In that resources folder, you'll find a copy of today's presentation with clickable links. So anything that's highlighted blue in our presentation, you'll be able to click, do a little reading on. That resources folder also has lots of goodies, experiments, activities from Sarah and Noose. They're going to tell you more about that. But that'll be a great thing to take a look at. And I'm dropping a certificate of attendance in there as well, so you can get some credit for attending this webinar. Let's see, what else am I missing? As I said before, we want to answer your questions in the chat today. If we happen to miss your question or you think of something later, please email us at info@vernier.com. We are happy to help you out. We're also available on chat, on the phone. However you need to reach us, reach out. We're here for you. The last thing before I hand you off to today's amazing presenters is that we are doing a giveaway of $100 towards Vernier sensors, software, whatever you're looking for. We are conducting that giveaway at the end of the webinar. It is only available for people who stay till the end of the webinar, so make sure you don't leave early. And I can't wait to hear what our presenters have to say. All right, thanks again, everyone.
Hi guys. This is Noose. I'm just looking over the comments. Emily from Columbia, Maryland. I taught in Frederick County, Maryland, and my daughter tells me they got a foot. So I don't know. I guess you're closer to Baltimore. So anyway, let's see what are we doing today. My name is New Hisim for those of you who don't know me. I'm a chemistry education technology specialist here at Vernier. I taught in Frederick County, Maryland for 34 years. Chemistry and Sarah and I were talking a little bit of smattering of physics there, here and there. Here I came in here 10 years ago and I do this. I help train teachers. I answer phone calls. I answer emails. I go to shows. I do training. Sarah, did you want to say a little bit about yourself?
Sure. So I am in Jackson, Mississippi. I teach physics and some engineering this year. I've taught chemistry and some biology in the past, so I'm just basically a science nerd. Um, so I'm excited to be here and help out. And I've been working with Vernier products for quite a while. I don't remember when I started using
I,
them.
I hear you. I started working with Dave Vernier in 1984. The no internet. It was just a telephone, you know. And so, yeah, I hear you. Let's see. What are we going to do? We're going to talk about apps just quickly, just to make sure everyone's up to speed. There's a few activities. We were thinking like, what would you do when it's cold? And so there's a few activities that are pretty obvious and some that may not be as obvious. So hopefully, you'll come away with something new. I'm going to do some chemistry stuff, and then Sarah's going to take care of the physics stuff because she's way better at it than I ever was. And then we have some shared files that, if you want to grab, of the activities or some data or, that you can fiddle around with. I'm going to fiddle around with some of it tonight. Something to be aware of is we're kind of okay. I don't know if I want to open up this can of worms, but how many people ever used Logger Pro software? Um, yeah, I did it from the first day. Love Logger Pro, but the problem with Logger Pro is that it's going away. We're not taking it away. Don't get me wrong. You can use it until it dies on you. I had a college today, Windows 11 update, and all their LabQuest minis stopped working. They were working fine yesterday, and then of course IT decided to update the computer. So we're recommending that you switch to our analysis apps, which are all free and all can be installed on Mac and Windows computers, not Chromebooks. But they can also be run on through the web on Mac, Windows, and Chromebooks. On iOS products, they have to be installed. On Android, I don't know because I don't own an Android. But there is a pro version of Graphical, and I threw a link in here if you guys are curious about it. This license key is active. I'm going to use it tonight. And so if you want to try it with your kids, by all means, grab that license key and put it into a copy of graphical analysis and have at it. You can kind of see, all the funness. I'm not going to get stuck on that. Tonight, Sarah and I are going to use graphical analysis. I'm going to use the pro version so I can demonstrate bar graphs because I think it looks really cool with bar graphs. But I also used the option to import video so that I could have some visuals for you guys, and that's something that's a pro feature. So I'm going to use the web-based version of graphical, but I'm on a PC. I could use the installed one. On my side, I'm going to be looking at these sensors tonight, and actually, really, for what I'm going to demonstrate, it's going to be pH and conductivity. I'm not going to demonstrate the temp probe because honestly, that activity is really cool, but it's like watching paint dry. So I did it last Saturday at my house. Oh, wait a minute, is this the right one? Yeah, oh no, this is not the right one. I did this one on Monday of this week. That's real live data, and it's in the sample data folder, and also the setups and everything. What you're seeing is a screenshot right when I actually did the experiment. And then I thought, let's see if it'll work with if you teach colligative properties and you teach freezing point depression, how does it work? Well, I was sorry, but I was a little bit surprised how good it came out. So I did the calculations for water, and I was getting negative 1.2 degrees Celsius, and by just calculating based on what I was using, it turned out to be a 0.24 molal solution. I should have been getting 1.3. So I thought, that's pretty. And I was really honestly putting a speck of. You'll see the notes there. By the way, the notes is a pro feature. You can't use it in the free version. You can do annotations. So free has annotations. Notes lets you get a little more interesting with the um, being able to add that. And where I'm trying to get them to add some more things like Logger Pro, because Logger Pro had all kinds of cool stuff. This was the setup Monday. This was me sitting there in the lab running this thing and calculating the, molal freezing point depression. And I was like, whoa, that came out pretty good. But this experiment, I put a couple notes in here. If this is a common one, a lot of people do. I did it with my ninth graders. Um, you want to use a smaller amount make sure it's distilled water if you want to get near zero. Um, and I use 3 milliliters, not five like Don Volz wrote in the original lab. And if you're using a Go Direct temp, you got to use a smaller test tube because it won't reach down. If you use a 15 or 18 millimeter test tube, it's not going to reach the water. So I ended up using, what did I use? It was a little teeny itty bitty dude. I thought I put it in here. It was like a itsy bitsy. I want to say it was 80 millimeters, so 8 centimeters height, and that worked really, really good for me because I could get the probe all the way down to the bottom of the tube. So just be aware of that if you're doing this freezing point lab. There's also a melting side of it, but I just did the freezing side just to see how that would work, and then I added calcium chloride. So with the calcium chloride, the I value was 3, and so
Noose, we've got a question. Are you talking about like a culture tube?
yeah, yeah. Thank you
Okay.
for reminding me. You're absolutely right. Those little culture tubes are perfect. And if you're doing this experiment, don't worry about them not being Pyrex. I didn't have any issue with them, but ideally, you'd probably want to get Pyrex tubes. Yeah, we used to get those culture tubes for free from NIH, and my lab aide told me to stop getting them because they would come in a box of 100. But if you broke them, who cared? Because they were really, really cheap. But yeah, thank you. That's exactly what it is. So then the other one, and Melissa just did this on Tuesday. So if you attended that workshop or that session. If not, I put it in it's right here in our a link to our website. So if you ever want to either sign up for, you guys must know this is where the sign up is, but also further down, what'll happen is Dylan posts the videos, like she said, like a week later, she'll post the videos and they end up on YouTube as well. So Melissa did this one called food science. It was like food for thought. It was like a winter comfort food sort of thing. And she did the uh Newton's law of cooling. I put if I put it in the shared folder. Let me go dig it out here real quick. Because if you're mathy like some people are, um, you might want to look at Newton's law of cooling and see how that exponential fit works. I put the experiment directions in the shared folder. So if you want to try it, you can either use my data or do it yourself. There's zero effort to this lab. I mean, you you know, I ran it for 30 minutes, but honestly, you could do a shorter time and it just doesn't look as impressive. Let me knock off all but one. So this was this plastic cup where here, no, it's this one right here that let me make it so you guys can see me. The that plastic cup is the one I used for the data for the plastic cup. So let's turn that one off and turn the plastic one. It was red, wasn't it? Yeah, there it is. So, I mean, you could use any of them, but let me put that in. And so then in it's exponential, so you can fit the curve in graphical. This is free, by the way. This you wouldn't need pro for this. So you can do a curve fit, let the kids explore, but what they end up coming out with was a real nice natural exponent. And then there's the Newton's law. Let me make this bigger so you can see it better. When you're teaching, up three dots in the top right corner, you can go to app preferences. You can zoom it up a little bit so it's a little easier for me and my old eyes. That's wonderful. So there's all the constants, and I don't remember, which one's which. X is time, Y is temperature, and then one of them is T zero. I think A is T zero, and B is T of the room. Okay, so that's the B, and then C is this constant. You can linearize this if you want. I did it this morning and it didn't make a whole lot of sense to me, but you can make a calculated column using just the free version and just use the exponential fit, which is here somewhere. The log, not log, this one right here. So you can use this exponential fit, and you can see there's a negative C. So someone's thinking Newton's law when they do that. So you can linearize this and make a nice linear plot, but I it's not something that I taught. And so, but it's a very mathy thing. I did this at a workshop once, and oh my, these math teachers went crazy. So use the Vernier stuff with math. So there is definitely some cool things you can do. So I put all those files in there for you guys. So if anyone has an interest, or maybe a math teacher at your school or something like that, you're welcome to share that. I gotta move along because I gotta leave some time for Sarah. I can talk. Can you tell that I can talk like crazy? Um, Ice melt, salt, calcium chloride, very common on the East Coast. I remember we could buy bags of that stuff, the little pebbles, and I've got it here. Um, what kind of surprised me, our neighborhood, or it's Oregon, and we don't want to put stuff down that's going to kill animals or plants. So they're using this blue melt stuff, and so I'm like, what the heck is that? It's 92% sodium acetate. What? The stuff that you used, the trihydrate, that's the stuff that they put in hand warmers that you heat up, you warm them up, and they get a form of supersaturated solution, and then you put you put a little, you bend it or you hit it, and when it crystallizes back out again, it releases heat. But I couldn't believe it. I'd never heard of this stuff. Never. In the whole time I lived in Maryland, we never used it. So I thought, well, I wonder how that would work if well, just what's in it, like you've got an I factor of 3 for calcium chloride, I factor of 2 for sodium chloride, I factor of 2 for sodium acetate. How does that relate to like the conductivity and the pH? Particularly kind of interested me because of the acetate. I'd never tried it before. In fact, have I even tried it before tonight? Well, we'll see. We'll see how good I do. So that's what I'm going to do. I'm going to measure conductivity and pH of some, well, fake fake snow. Okay. Now, actually, I melted it, so there's also some melted solutions there. Our pH probe doesn't do well with different temperatures. It's not temperature compensated. The conductivity probe is temperature compensated and even has a temp probe built in that you can access. The Go Direct one does. You can turn that temperature probe on and read the temperature from that. So if you're doing like temperature versus solubility or something like that, you could actually turn that on. The Go Direct one, not the old wired one. The old wired one, you could do what I'm about to do, but you couldn't pull up the temperature if you want. I'm gonna use this conductivity probe because it's more common for especially high school teachers. We do sell what's known as a platinum cell conductivity probe. That's right, I did test this because I wanted to see, how much different they were. Almost nothing. The difference is this one has an epoxy body that can stand up to other solvents besides water.
And Noose,
There's,
really
yeah,
quickly, we have a good question in the chat. High concentration of ion will have a high conductivity, right?
yes, it will. Yes, it will.
Right.
Yeah, that's the whole point. So that's good. Say, hey, Mala, that's absolutely you are right on it. Okay, so let's take some distilled water. I'm gonna do 150 mils for everything. And I've got some pre-measured out salts, but let's just test Vernier Beaverton um, um, water. Okay, so this is not tap water. This is This is distilled water. I'm going to use the flat pH, and the reason is let me show you the difference. The flat pH has a lot of different functions. That's why it's a little more expensive. But if you look at the electrode part, you can see that there's much less glass exposed just right on the very end. The standard pH, we would lose. Now, back in the day, we had the one piece ones. Now you can just buy the electrode, so you don't have to buy the whole thing. So it's a lot cheaper if you break them. Or if you want to replace the electrodes. I mean, 5 to 10 years, they start to act up. The flat pH is more expensive, but it's less problematic when it comes to breakage. So I'm going to use that. Functionally, they're identical. You're not going to notice a huge difference. Let me connect them real quick here. I'm going to connect them by Bluetooth. So I turned the power on. You might notice their red LED is flashing. So I'm using the web-based version of graphical. And so I'm going to hit this. Now, where I'm at the office, right? There's like a million probes around me. If you're in your classroom, you have to do is you have to look on the back of these probes, find the identifier, and it's right by a barcode which has no use. But one of them says Y6. So I got to find Y6. There it is. So that must be the pH probe. Yep, that's the pH probe. And so I'll get that. And then the other one, the conductivity probe is 38. So let's go connect that. How many can you connect by Bluetooth? Up to three. There it says Con 38. Can you share it with other computers? Not straight from the probe. Bluetooth is a one-to-one connection, but what you can do with Pro is you can share your data. Like one student could be the source of the data, and then that student could transmit his data to his lab partners. The way Vernier does it is we only allow the data. The analysis they have to do on their own. Now, the other thing I want to do tonight is I want to collect different samples. So I don't want time. I want to be able to tell it what sample I'm collecting. So I'm going to go down here to the mode option and I'm going to change the data collection from time to event based. And my event is just going to be the sample and I'll put the formula in or something. Okay. So I'm going to hit done. And then let me get the meters back up because I changed the mode here and lost my meters. There we go. There's little itty bitty meters down here, but I like these big ones. I just think it's a little bit nicer. So I've got this probe sitting in distilled water, probably some carbon dioxide got in there. So, its pH is, you're not going to get 7 for distilled water. Super common misconception. Even at Walkersville, where I taught in Frederick, we had a still that had like a charcoal thing to keep the CO2 from, less CO2 from getting into distilled water, but just store it. And we had big carboys, but the CO2 in the air. So what you're doing is when you do events with entry, you'll notice that it's got this choice that says collect and keep. No rush. Oh, I forgot to turn on bars. Let me turn bars on. With the pro version, I can have bars, and I just think they look pretty. So I'm going to turn them off. So anyway, with events with entry, no rush. You just kind of watch the meters until they stabilize, and that's about all I'm going to get. And then I hit keep, and it says, what is the sample? And I say DI water, although ours is distilled. It's not deionized. And it comes up and says, hey, this is not a number. Are you sure you want me to do this? You can, with the Pro, you're able to do that. If you use the free version of graphical, the only option is numbers. So you would have to keep track, of your numbers. So what I'm going to do with this one is it's distilled water. I'm just going to add salt to it. Now I already measured out the salt, and I put some notes in the shared folder. I have three salts. I have sodium chloride, calcium chloride, and sodium acetate. Okay, so here are my three salts. The masses of these are equivalent masses. You can explain that to your students or not, because they are not the same that weight. If you put these on a balance, they're not going to weigh the same. And so, what do you mean they're equivalent masses? What's equivalent about them? Okay, but I wanted the moles to be the same so that the argument could be we could look at the Van Hoff factor and say, okay, this one has two, this one has three. So I wanted the moles to be the same. And so, but when you're talking with your students, what you might do is say, well, what is the same and what's different? Okay. And these are equivalent masses. Depending, like if you're doing this now, you probably already did moles, and so your students probably can get to it. Yeah, so anyway, so watching, notice the pH didn't change very much. Oh, what's that all about? Sodium chloride, a strong base and a strong acid. But notice the conductivity has definitely changed a little bit. So let it stabilize, hit keep, and then put in, what this is. And look at that. Okay. So, I need two graphs. This is too boring. So graphical analysis, you can have two graphs. So I can have, this is my pH, and notice the difference in conductivity. Ooh, baby. Okay, now let's take these out, and I'm going to rinse them in a beaker of distilled water, get a fresh beaker up here. Let me get that magnet back, because I like the idea of stirring it. I stirred the melting point thing I did over the weekend. I stirred that as well, just to kind of keep the water, about equivalent weights. So I'm doing this fast, so we're probably not going to get super duper great data, but I think you'll get an idea. So this is distilled water again. Notice it's still collecting, it's not collecting data. It's just waiting for me. I'm going to take calcium chloride. Notice the nodules of calcium chloride. This is cool stuff because it's exothermic when it dissolves. So I used to do a lab first day of school. I did it first day of school before the kids even had their safety stuff. I'd have lab goggles sitting out, and we did an experiment with vinegar and baking soda and vinegar and calcium chloride and a temperature probe, just to kind of compare, and so it was kind of a cool thing to do. So what you want to do is give that a chance to dissolve. See how that magnet's bouncing around? It's not going to hurt the conductivity probe. That has graphite electrodes, and so unless it really bangs into it. With the pH probe, if you have the one with the glass exposed bulb at the end, you got to be a little more careful here, because that one, I could, if I'm a little too nonchalant, I could mess it up. But this one with the flat pH, it's not nearly as exposed. Okay, so those numbers are pretty stable. Ooh, interesting with the pH. Let's keep that. This is calcium chloride. Oh, they're coming with subscripts and superscripts and some update of graphical analysis. I don't know um, if it's going to be free or whether it'll be you have to have Pro for it, but I know they did mention because I, you know, I was one of them that said, "Hey, it would be really nice if we could drop in some real formulas instead of this made-up stuff." So, all right, there's my last one. This I'm curious about the acetate. So, yes, it's the same number of moles, and I did all the calculations and stuff, so it's in the sample stuff. But I didn't know. Do they use this in your area? Does anyone know if they use this in your area? Because I don't remember. Now, Ace Hardware sells it. Um, yeah, I looked up the blue heat thing that they sell that they're using here in Beaverton in my neighborhood, and it was like, huh. It's like, yeah, the Ace Hardware has it, and you can buy it from some other places, but I never, never you know, you school use is it expensive? Doesn't it see and is it like, you know, I don't know. I don't have any idea. The only thing I ever used it for when I taught was the supersaturated solution. I did a lot of demos with that. All right, that's enough talking. I got to give this over to Sarah in a bit. Let's take a look at that one. So this one is sodium acetate, NaAC, and let's compare them. So look at that. So I'm going to stop collecting data and let's see. Calcium chloride, you got the two chlorides. The pH is lower but higher than sodium chloride. And then look at the acetate pH. Look at that. Whoa, baby, you got a strong base and a weak acid. Look at that. And then down here, conductivity just it kind of sort of maybe a little bit like the sodium chloride, but less than the calcium chloride. I don't know. When you look at the Van Hoff factor and you go and look at the ratios, I did a demo and it's a webinar like from 6 months ago where we looked at sodium chloride, calcium chloride, and aluminum chloride and got very nice ratios for the molarities. I don't know. I didn't. This is the first. You guys are seeing this for the first time. I need to save this file so that you guys can have it because I don't think I have this file. So I'm gonna save it here. So this is going to be conductivity and pH of salts. And then I'll eventually move it into while Sarah's talking, I'll move it into the sample folder so you guys can have a look at it. Last minute here, Jonathan, if you're thinking of salts, I don't believe that's iodine. Last is
They
an
were asking,
iodine.
does the
Yeah,
sodium chloride need to be
I
iodized?
think they iodize it for health reasons, and then you can buy nine on it. But I would think it would cost more. So I would think maybe I don't know. Good question, Jonathan. I don't have a good answer. I am going to turn this all over to Sarah because I'm done and I'm going to monitor the chat. So I'm stopping sharing. If you need something, just throw it in the chat, and I'm going to turn my microphone off unless I need to yell at Sarah and say, "Hey, they asked about a thing I don't know the answer to." So go for it, Sarah.
Just yell at me. That's fine. Um, so hi everybody. I am set up in Mississippi, and I was going to go over some motion experiments, which use a couple other probes. Let me pull up. Well, I had it a second ago. There we go. Go all the way through to where we were. Sorry about that. Um, so I'm going to be using a motion detector, a Go Direct motion detector, and the sensor cart. Um, and first, I think I'm going to do the motion detector. I have put all of the labs that I'm going to do. It's my version of labs, but they've been based on Vernier labs at some point. I've put them all in the shared files down here. And then um, you should be able to see sample data from each one as well. So I'm going to go to this. Okay. So now that I've kind of moved around, I've got to be able to start things, but that's about it. So I'm going to go to graphical analysis. Y'all can see my screen now. And I've turned on my motion detector at this point. Let's see. There it is. Students, when they connect, they always seem to, half of them have it on dark mode. So I have to tell them to come up here and go to app preferences and turn it to light mode. But I am, for the graph matching lab, I basically am trying to get students to understand, how position time graphs and velocity time graphs and those things can, how they work. The motion detectors, I first have them kind of walk back and forth with the motion detector. So they can figure out that moving toward the motion detector is the negative direction, moving away from the motion detector is the positive direction, because they can't change that part. And then for this lab, Vernier has this lovely thing. You can come down here to this graph icon and go to add graph match. And the students see this position time graph. I do this on 2 separate days. I do the position time graphs one day, and then the next day students come back and they do the velocity time graph. And so they have to figure out how, they have to predict how they would walk this. And then they have to, actually walk it with their partner. And each partner has to do this independently. I have them use a whiteboard to kind of see them a little bit better from the motion detector. But I tell them not to do this sort of thing. They like to do that. So here, let's see. Positive direction would be moving away from the motion detector. So it looks like I need to start at 0.6 meters. And there's this lovely thing down here that tells me my position. So I'm going to need to get a little bit closer. I'm just going to move that here. So if I start at 0.6 meters, or I'm turning around for y'all, trying to figure out. I'm not quite close enough. Here as well. All right, so that looks like I'm starting about right. And we're just going to start collecting. And they have to walk at the right rate, kind of watch it as they go. I'm not quite in the right spot, and they have a lot of fun going back and forth with it. And, then they walk the wrong direction, and it's a fun lab for them. And they also get to really understand, okay, positive slope means one direction, negative slope means the other. The steepness of the slope is the speed at which they're moving. And they have to answer a few analysis questions about it. But this is a fun one. It also introduces them to graphical analysis and kind of how to connect the motion detector, because it's one of the first labs I do with the motion detectors and with the graphical analysis software. I have them come back the next day. So I have them save it. I have them save everything they do. And then they come back the next day, and I'm going to just reopen. I'm not going to save that. I could have just started a new experiment. But we're going to come back here to sensor data collection. And when we do that, still going to use the same motion detector. The velocity time graphs are a lot harder. And this is where it really gets interesting, because students are so used to seeing a horizontal line meaning no motion, but on a velocity time graph, a horizontal line means constant speed. So this one gets a lot more difficult for them. So we're going to come down here, add graph match. And I have every student have their own graph, so they can't have the same graph as their lab partner, which means that they have to discuss it with their lab partner, and they get a number of different graphs that they walk, hopefully reinforcing the material. So I'm going to come down here and go to add graph match, just add another one. So that would be the second student. All right, so this one looks like I would be moving in the negative direction, so that's toward the motion detector at a constant speed, and then away at slightly less speed, and then back toward the motion detector. It doesn't matter where you start quite as much, because it's all about the speed at which you're walking, not the position. So I'm going to come over here and see if I can do this sideways. Nope. Well, there was the noise from so not my best. A little bit of noise there. I think it was picking up my shirt instead of my board. One more time. Let's just collect again. Maybe it's, there we go, a little bit better. I'm moving the board too much. Usually I have it in front of me and I'm doing more of this motion instead of sideways. But you get the idea. They have a lot of fun with this one. So, any questions so far?
This is one of our major calls is or tickets is why am I getting so much noise from my motion detector? And there is an article on our website that similar to what Sarah was showing about what to try to improve your data.
I tell my students that they need to glide. And so usually they have the screen in front of them so that they're not looking sideways and doing this. With my setup today, it's just not perfectly ideal. But I tell them, I'm like, you need to glide and be very still and try not to rotate forward. They get the hang of it. They also learn a lot about what the motion detector is doing and how it's analyzing, how it's picking up the material, how it's picking up that data, and what it's doing with it. So they understand why tilting the board makes a difference. All right, so I'm going to go to a new experiment again. And now I'm going to kind of switch gears. So my motion detector is on because it's over there with you all. I can turn it off later. But for this one, this is the first lab where students start scaling their data a little bit better. So I've got the Go Direct sensor cart. And I have my students, this is the long track. I've got the long track, and then my students use one that's about half this length. I'm going to use the long track, and I'm definitely putting this in a position. I can't see if I can see me. Let's see, I'm going to move that. I'm putting it in a position so that when it hits this end stop, it will bounce just because there's only one of me. Usually I tell my students, make sure that your end stop is really secure before you send it down the track, and have somebody releasing and somebody catching just to be on the safe side so that my carts don't end up on the floor because they're teenagers. So I'm going to come over here. Let's see. Connect now to my Go Direct motion cart. Oh. I'm going to disconnect from that. It's still on, but I turned it on. I know it's charged. There it is. There's the red light. So go to my cart. And this point, I first have just a little motorized car, which has constant velocity. And so I tell them to put the motorized car there, and that's in front of a motion detector. And they use 2 graphs for that. But then now, I'm going to see if I can, move stuff around. Move you down here. I want my students to see position time, velocity time, and acceleration time graphs and see how they're all related. So I'm going to come up here and I want 3 graphs, which is kind of behind there, but there we go. It automatically defaults to position time at the top, velocity time, and then acceleration time on the bottom there. All right, so this was really simple. We're going to start this over here. We're going to say collect and let the cart go. Okay, well, you can clearly see that I've got great data from the carts. It's nice and smooth. There's no noise, which is lovely. But there's also a lot of information that I don't need. So sometimes I tell my students to set the time to a shorter time frame. But for this, actually, the pro version of graphical analysis, if you get that, it allows you to take all of this data, the data I don't care about as much, and you can come up here and select strike through, and it will strike through that data. And then it's lovely. I'm going to press this little magnifying glass over here, and it zooms to the data, which this you can see is a nice curve, which it's supposed to be. It's accelerating downward, which is what is expected. My velocity is increasing in the negative direction, which is also exactly what I was expecting. And I could adjust that a little bit. I'm not going to at the moment, but I think on the sample data that I uploaded, I did kind of adjust the graphs a little bit more. But this acceleration time graph is really hard for me to see. I mean, I can tell it's linear there, but it's not, I don't really need a scale from -2 to 14 meters per second squared. So I tell my students, you have to come down to the graph options. At the very bottom, it says edit graph options. And I tell my students that they need to scale their graph to something that looks reasonable so I can actually interpret their graph. So I'm going to have it, let's see, I'm going to try -1 to 0. Oop, to 0, not -0. And that one you can see it's a pretty linear graph. I guess I could have done -2 to 0, but that allows me to see that this is pretty much a straight line all the way down. I guess that was the wheels is on my track. This might be a little old and dusty. So I have my students do 4 scenarios. The first that I just did was going, and the carts have a lovely little positive and negative here. And so this one was going down the track or accelerating in the negative direction down the track. And so increasing its speed in the negative direction. I then generally have them turn the carts around, but so that it's going down the track in the positive direction and things like that. For this, for y'all today, since I still want it to bounce off the end, since I can't be at both ends, I am going to, down here, oh, I should have zeroed it too. I usually have them do that. You can reverse the polarity or reverse the direction of the cart. So now, same motions we just had, we're going to be moving in the positive direction. So still, so accelerating in the positive direction and moving in the positive direction as we go. And I am going to zero it. I'm going to say, okay, this is now 0. And collect the data. I'll move out of the way so y'all can actually see it. Maybe I'll just chase it. Decide to catch that one. And again, if you don't have the pro version, or if your students are, just something's going on with their computer, or they can, I've done this in the past too, just select the data that they want. So I'm going to select, I just want this data. And if you have that selected and you say, okay, let's zoom to the data, zoom to selection this time, it will give you the same sort of thing. And you can still adjust, like this scale, 0.15 to 0.55 meters per second squared doesn't really show me exactly what I want to see. I'm going to tell them to go from 0 to 1. So you can see it's a nice flat line. But this one, I would probably move up a little bit, start at 0. And then you can see that this one is a pretty curve over here of, well, let's try this again. Whoop, there you go. So the nice curve here. And again, I would probably have my students make it a little bit, more visible, but it's a good skill for them to analyze a graph. So not only just have the software produce it, but then they have to interpret the graph, and they have to make sure that the graph is something that's reasonable for me to look at, and that they can clearly see the curve and clearly see the linear graph and clearly see the horizontal line there. And then if they do select the wrong section, they can always just go back to the original data. I'm going to strike through this because it makes it easier for me. And strike through, and then might as well strike through that beginning stuff. I don't need that. Ooh, let's strike through a little bit more even. Let's go with that section. And analyze it from there. Again, I would probably adjust the acceleration time graph. So those are easy labs. They're quick to set up. They need, the equipment, but it also helps. It's the first time my students see the motion detector with the graph matching lab, and it takes several iterations of the graphs, of seeing the graphs, producing the graphs, analyzing the graphs, for it really to sink in for them, because they're not used to seeing a graph with a negative slope. That means you're speeding up, like that first graph that we just had where it was speeding up in the negative direction. And they have a lot of fun with them. They like to be back in the back of the classroom, with the carts. I just have to make sure that they, continually reinforce the end stops and, aren't too wild. So those are, then I have my students save everything, and they also have to take screenshots and turn in screenshots. But if you look on the shared folder, we'll go back to the shared. I have in here, so this is that's the lab we just did, the buggy and cart lab, and then the graph matching lab is here. That one's modeled off of Vernier's years ago. I just ended up retyping some things, but if you have Vernier's graph matching lab, it's the same one. I think the cart lab is very similar to the one that they publish as well. And then I have some data that goes with it if you want to just kind of use my data or have your students analyze. I've got the cart, and I've got all 4 scenarios. I've got accelerating, down the track in the positive direction, up the track. When they do up the track, yes, yes. Nope, not good. Make sure that you can. So when the students go up the track, I just tell them to start collection and then give it a gentle tap. The smart carts make it much easier. If you don't have the smart carts, like my school is still purchasing them in batches, right? But if you're still using some of the older carts and you haven't gotten to the smart carts, there's a lot more noise because their hands get in the way, right? And so that's when it's really important for them to like focus on the portion of time when you were actually having the cart go down the track. And they also, with the previous ones, to go ahead and change this to like a 2-second duration, just so they don't have as much noise. But they have to be really careful about where their hands are when they're using like a motion detector in a cart as opposed to the smart cart. The smart cart gives beautiful data. I've been enjoying it, and I'm looking forward to my school purchasing some more of them in the next round of purchases. So are there any questions? I guess I can, so y'all can see me.
I've been trying to keep up. There's been some great comments. They love your analysis and it's like, gee, I wish more people instructed this way, and really, really nice comments. So,
Oh,
yeah.
it's fun. The
Yeah, I
students
just made
like to
the
be up
comment
and out
that,
of their seats too. I mean, since it's physics, I tend to get them out of their seats as much as possible.
yeah,
Uh,
I added the comment that the sensor carts also have a force probe built in, and
they do.
so you can do second law stuff with it, which is really good.
Well, and I'm looking forward to this week. Actually, I'm doing a impulse and momentum lab with the carts
Oh,
where they collide, and so you can see the force and the impulse and the
yep.
uh, yeah. I've
And
really enjoyed the smart carts.
you can even integrate the force versus time. So
Mm-hmm.
yeah, yeah, it's
Yeah.
kind of nice. Graphical analysis is definitely improving. Um, so that there's
Oh,
lots
and
of
let me actually, while you're talking about that, let me mention I don't have my students at my level, but at other levels of physics, I have as well. You can have the students come up here and add a curve fit. And so they have to figure out, okay, is it linear? Is it quadratic? And they can analyze each of those curves, and you can get, you know, let's see, that one should be quadratic. And there it is. Now I've got my screen in the way. Woo, move you over here. But then they can analyze all of that data mathematically as well, and see kind of how that compares to the graph below it and things like that. Mine is more of a qualitative lab, but I have made it quantitative at different levels.
Yep. Yeah, it's nice that you could modify this for ninth graders or
Mhm.
AP physics, and so that's wonderful. So
I'm
folks,
gonna,
we are kind of winding down. Did you have anything else to add, Sarah?
I don't think so.
Okay, I don't
Why
know
don't
where
I
we're
transfer this back to you? I'm gonna let you share your
okay.
screen.
That'd be good, and then we
Your,
can we
yeah.
can get because I know Dylan's got some stuff that she probably wants to do, and
Okay, where's stop sharing?
so
I know it's right here.
yeah, you stop sharing, and then I'll start sharing again.
I thought I
Let
had
me
it.
get
Share.
Yeah,
Oh,
when
stop
you
share. There
share
it is.
that little
There it is.
doodad flies around, and I know that thing can be a real pain in the neck. So let me see, where's my screen now? Okay, mine. I was running around trying to find stuff for folks, so let me get back up here and get screen number one and share that and go back to the presentation, which might as well make it fill up more of the screen. And let's see. So boink. Well, there's all the fun stuff you did. Oh, well, so we're here. Dylan, was it before we go on? Bad bread. Oh, I missed something. Low at the bread. Oh. So any last minute thoughts, questions, concerns before Dylan tells us who won the gift certificate? I'm leaving it peeking at the chat right now. I have pH probes and enjoyed using them in Chem 2. Fantastic, Beverly. I'm glad to hear it. Yeah. Yep. Yeah. Yeah.
All right. Well, as news looks for any last minute questions, because we do have 5 minutes, so we are not in a huge rush to get out of here if you all are still formulating your questions and ideas. As we've been chatting today, I entered everyone's names into a random name generator to select the winner of today's $100 gift certificate. And the winner today is John M. So, congratulations, John. We are so thrilled to offer you $100 towards Vernier sensors, software, however you want to use it. I'm going to email you after this webinar and just get some information on how to get that gift card to you. And then you'll get some easy, here's how to use this instructions from our team. So, congratulations. And then I'm looking at the chat. Does anyone have any questions? I think I see a raised hand. Annette, it looks like your hand is raised. Drop your question in the chat and we would love to answer.
There was a couple comments about drop counters. I would highly recommend if you go to our website, you can schedule a free 1 hour personalized training. Zoom, it's I'm not going to come out to your school, sorry. Uh, but if you go to our website, it's under professional development. And I would say pH or conductivity and drop counter, that's a whole area. It's not that difficult once you've learned how to do it, but the drop counters have to be calibrated. That's just a requirement. And pH probes, depending on the experiment, if you're looking for the Ka of an acid, you got to calibrate it. But if you're looking for the equivalence point, believe it or not, you can get away without calibrating it as long as it's performing properly. So my suggestion would be contact me. Let me go back to the thing. Um, there's many ways to contact us now. Um, and so I would love to get together with you, anybody who needs help with anything. But pH and especially if you're doing a acid-base titration with a drop counter, it's not like it's a brain surgery, but it's just you need to see it. NSTA last year, ChemEd last year, I did conductivity titration and I did I'm drinking acid, which is an acid-base titration, all with drop counters. So we were able to squeeze it into less than an hour. So by all means, if you're curious about that and want me to do a demo, or if you want to borrow one, we have a preview option where you can borrow a sensor too, and you can keep them for 30 days. And if you want to buy them, you just pay the bill that comes with it. If you don't want to buy it, you just pay the shipping to send it back. So it's a free preview option. But by all means, contact us. So, all right. Hey, Dylan, who won?
So our winner was John M. And we've done our celebration. Trina did just drop in the chat. I've been watching. We missed a question. Quote, are we able to make a model line yet? That is, we added our own equation that goes over experiment data.
Yes, but you have to have now that Trina, are you talking about what Sarah was showing with um because with yes in and I don't have a motion detector here, so I can't do it. But if you've got a motion detector connected, you can put in your own line for students to match. And if you have Pro, I think I can demonstrate that. If you have Pro, you can do manual fitting. So I don't know if that meets your need, but there is an option to do manual curve fitting. So that might be similar to what you were doing. Yeah, you can add a prediction, but Sarah, I don't know if you've seen it. It might be that you haven't updated yet. There's an option with um Graphical Analysis Pro and Cur and um what is that thing called that Sarah just showed us? That you can actually put in your own matches, so you're not limited to just the ones we do. Yeah, like Logger Pro lets you do, and that's been a request from physics teachers to be able to add our own match. But I believe that's a pro feature, and I don't have a motion detector here, so I can't show it to you. But yes, that is there for motion. Um, and then otherwise, like Sarah pointed out, you can put in a prediction, but that's something that kids would do. So hopefully I answered some of that question. Um, so sound analysis show how what happens when you double the frequency. Yeah, that would. So okay, well we're at the time. So Dylan, you announced who won.
Yep.
Okay, and hopefully they got it. Is there a video for calibrating drop counters? Not yet, Nadine, but that and calibrating pH probes is coming, and I'm going to try to make them as short as possible. So send me a message, and I'll send you a link to my rough video once I have it. All right, I'm going to shut up. I'm going to quit sharing my screen, and we are going to call it a night here, folks. Thank you so much for
Yes,
these
Thanks,
thanks
y'all.
wonderful
everyone.
questions. Don't hesitate. Don't be stuck. Contact me, and if I don't know the answer, I'm going to send it to Sarah
Yep.
and say, "Hey, Sarah, this teacher's having
I'll
trouble,"
send it to
you
Dylan.
know, and we'll get an answer for you because we're all teachers here. So, okay.
All right. All right. Thanks, everyone. Have a great rest of your night. Have a great
Thanks,
weekend.
y'all.
Stay warm, stay
Oh,
cozy, and we'll talk to you
yeah.
all soon.
Yeah, where's my snow?
Yeah.
I got grabbing my Beaverton snow. Here's my
Yep.
Beaverton snow.
3 inches now.
Yep,
All
down to
right.
3 inches. Yeah. All right, folks. Have a good
All right.
evening.
Ending it now. Bye now.